How does energy storage help with peak shaving? Imagine a hot summer day when everyone is turning on air conditioners at once. The power grid feels the pressure, and electricity prices spike. That's where energy storage systems come into play. They act like a smart savings account for electricity. These systems, especially battery energy storage systems, store electricity when demand is low or prices are cheap. Then, during those busy peak times, they releases that stored energy back into the grid. This reduces the amount of power utilities need to draw from the main supply when everyone is using the most. It's like having a reserve of energy ready to step in when demand is at its highest. Utilities use this method to cut down on demand charges, which are fees based on the highest power usage in a billing cycle. If a factory or a shopping mall uses a lot of power suddenly, their bill jumps. But if they use stored energy during that spike, their peak demand drops. This can save thousands of dollars each year. Larger battery systems can handle bigger loads, making peak shaving even more effective. For example, a battery system with a capacity of 1 megawatt can shave off a peak load of the same size, smoothing out the demand curve. Peak shaving also makes the grid more reliable. When demand spikes, the grid can get overloaded, causing outages or voltage issues. Energy storage helps prevent that by balancing the load. It also delays the need for costly infrastructure upgrades like building new substations or transmission lines. Instead of spending millions on new equipment, utilities can use existing batteries to manage demand. Another big benefit is how energy storage supports renewable energy sources like solar and wind. These sources produce power when the sun shines or the wind blows, not necessarily when people need it most. Storage captures that excess energy and releases it during peak hours, reducing reliance on fossil fuel plants. This helps lower emissions and supports sustainability goals. Operational flexibility is another key point. Utilities can control when to discharge stored energy, responding to real-time demand changes. This helps with demand response programs, where consumers are encouraged to reduce usage during peak times. Plus, by decreasing peak demand, energy storage reduces the need for peaking power plants, which often run on dirtier fuels and produce more pollution. All these benefits come together to make the grid smarter, more resilient, and more environmentally friendly. Utilities analyze their customers, usage patterns, the cost of different energy sources, and battery capabilities to design effective peak shaving strategies. They look at how often demand peaks happen, how big they are, and how much energy storage capacity is needed. They also consider how efficiently the batteries can store and releases energy, and what the total cost will be over time. In the end, energy storage systems help utilities manage demand better, cut costs, improve grid stability, and support cleaner energy sources. They are a key part of building a smarter, more reliable future grid that can meet the needs of everyone while protecting the environment.